Hello again, class. This video is going to conclude our lesson on 5.3, dividing polynomials. This last section is dividing using synthetic division. In class, I want you to pay very close attention to this lesson because you've never done anything like this before. This is all brand new to you, and the algorithm or the pattern on this could be very difficult if you aren't paying very close attention. So make sure you pay very close attention here. We are dividing using synthetic division, which in my opinion, class, is the most efficient way. I think you're going to like this way the best for a couple different reasons. One is that it uses less paper, it doesn't take as long, and that's kind of a benefit for a lot of high school students who don't like to write a lot. So I think this method will be valuable to you because of that reason. But I also think that it's quicker and it's a little bit easier as well than using long division. So pay very close attention. Now I want you guys to notice this problem, x squared plus 2x minus 24 divided by x minus 4. This is our same problem as number 3 on our exact same notes. And notice what we got on number 3. We got the answer x plus 6. So we did that using long division. Now I'm going to prove to you how using synthetic division we'll get the exact same answer. So now once again, pay very close. What we're going to do here, the first thing is you're going to draw a division bar again, except this time it's just going to be upside down. So draw this on your paper. We're going to have our division bar look like this instead of the other way. So we have this written on our paper. Now the next thing is that our dividend is going to drop down. However, we're not going to write it just the way it's written. We're actually just going to pull down the coefficients, which are the numbers in front of the variables. So how many x squareds are there? There is 1 x squared. So we're going to pull a 1 and bring it down right here. Our next coefficient is the number 2. So we're going to pull that down and we're going to bring it right here. And our last coefficient is our constant term. It's a negative 24. So we're going to put that right here. Okay, so that's the first thing we did. All we do is we bring down our dividend, and it's the coefficients of our dividend, which is 1, positive 2, and a negative 24. Now on the outside of my division bar is going to be this x minus 4. But once again, I'm not going to pull this x minus 4 out here. What I'm going to do is I'm just going to take the opposite of what is written here with this negative 4. The opposite is obviously a positive 4. So I'm going to bring out a positive 4 right here. It's all part of the algorithm. What you basically do here is this x minus 4 is a factor, which means that it equals 0. We're going to talk more about that in more detail later on in this unit. But for now, just know that this x minus 4 right here is a factor. So we want to find when that equals 0. When that equals 0, I add 4 right here, add 4 right here to make x equals 0. Or sorry, to make x equals 4. X equals 4. And that is why this positive 4 is now over here on the left. Okay, so if you want to think of it how it's always the opposite of what is written in here, that's just fine with me. If you don't know what that is, just set that equal to 0 and solve for x. So we have this 4 out here. All right, now here's the next thing that we're going to do. I probably should have drawn this division bar a little bit bigger. All right, now memorize this pattern. It's going to be very valuable as we go forward. The first thing that we do is we just drop down this first coefficient. So this 1 is going to drop straight down and it's going to go right here. Now the next steps are going to be alternating multiplication and addition. We're going to multiply, add, multiply, add, multiply, add, multiply, add until we go all the way to the right. And here's what I mean by this. Pay very close attention here, class. We take 1 and multiply it by this 4. 1 times 4 is 4, so we put a 4 right there. Once we do that, we now add 2 plus this 4 gives us 6. Once we bring that down, we just repeat this pattern. We take this 6 and we multiply it by the 4 again. 6 times 4 is 24. And now we add a negative 24 plus 24 is a 0. So now class, these are now our new coefficients. Our coefficients are 1, 6, and 0. Now our answer isn't 1, 6, 0. Our answer lies with these numbers, but they are the coefficients of our answer. And here's what I mean by that. Our highest degree was x squared. Everyone sees that up top? X squared at the top. That was our highest degree. When we divide using synthetic division, these numbers right here represent our coefficients from 1 degree down from the highest power of x. So if our highest power of x was a 2, these numbers right here, here, and here represent the coefficients 1 degree less than that x squared, which 1 degree less than x squared would be x to the first. So this one right here is the coefficient in front of our x term. So it's going to be 1x, or just x. And then we just go in descending order from there. So this 6 right here, that becomes our constant term. So we put a positive 6. And then 1 less than our constant term is our remainder, which, as you can see, our remainder is 0. We don't even have to write it. So our answer is x plus 6. And as you can see, we got that exact same answer when we did that on number 3 using long division. So we get x plus 6 using long division, or x plus 6 using synthetic division. One thing that might be going through your head right now is, Mr. Berge, this is so much easier if we just long divide. Synthetic division is too hard to memorize. You might be feeling that right now. I'm willing to bet by the end of the notes, you're going to see how synthetic division is quite a bit easier and quite a bit quicker the more familiar you get with it. So stick with me here for 3 more problems. Here's number 6. So the first thing we do once again is we draw that division bar. So draw it again with me. There's our division bar. Now what we do is we bring down the coefficients from our dividend. So our dividend is x cubed minus 6x squared plus 1. Now one thing we have to be very, very careful of here, class, this is another huge step with synthetic division, is we have to make sure that we put in our placeholders. Our placeholders means that if we don't have a certain term in that polynomial function going in descending order, we have to put a 0 in for that. And here's what I mean, watch closely. We have 1x cubed. We have a negative 6x squared. So a negative 6 would go right here. So we have 1x cubed, a negative 6x squared. If we were to go in descending order, we would have a 0x right here, wouldn't we? We don't write 0x because it's understood that there aren't any x's. But if we were to truly write this in descending order, we would have a 0x right here. So we have to put that placeholder of a 0 in there. We have to put in descending order all of our coefficients. So we have to put this 0 right here. So it's 1x cubed, a negative 6x squared, 0 x's, and our positive 1 for our constant term. So make sure that you're very, very cautious of doing that. One little hint for you, if our degree is 3, you should have 4 terms right here. If our degree is 7, you should have 8 terms right there. If our degree is 2, you should have 3 terms right there. It's always 1 more than what our degree is. And then the number that goes on the outside of the division bar is our divisor, x plus 2. Remember that it's always the opposite of the positive 2, which is now a negative 2 goes on the outside. All right, let's become familiar with this algorithm. So what we do is we drop down our first coefficients. We're going to drop down this 1. And now we multiply, add, multiply, add, multiply, add, multiply, add, all the way across until we're done. So we multiply. 1 times the negative 2 is a negative 2. And now we add. A negative 6 minus 2 is a negative 8. And now we multiply. A negative 8 times a negative 2 is a positive 16. And now we add. 0 plus 16 is a positive 16. And now we multiply. 16 times a negative 2 is a negative 32. And now we add. 1 minus 32 is a negative 31. See how that was a little bit quicker than maybe doing the long division aspect of things? And you're only going to get faster and faster the more that you do of this. So it really is quite efficient. It's a very efficient way of dividing polynomials. Now remember, our answer isn't 1, -8, 16, -31. That's just silly. These numbers represent our coefficients from 1 degree down from the highest power of x, which sounds confusing, but it's not so bad. Our highest power of x is this x cubed. So now starting at x squared, 1 power down from x cubed is x squared, we're going to have 1x squared, which I don't even have to write 1x squared because it's understood to be that 1. So we have 1x squared, a -8x, a +16, and then this term right here becomes my remainder. Now one thing I want you to do with the remainder, back in the 3rd grade, I suppose that you learned maybe with a remainder of a -31, okay, or else you did like a decimal or something like that. Here's what I want you to do in advanced algebra. Instead of just putting a remainder -31, I want you to put a -31 over what your divisor is. Your divisor is x plus 2. A -31 over x plus 2. And this, class, is what our answer is. X squared minus 8x plus 16 minus 31 over x plus 2. Let me just make sure in my notes that we did this right. Yep, looks good. If I want to explain to you that remainder aspect of things, if you don't care, you could probably just fast forward maybe a minute and a half or 2 minutes. But if you're curious why that remainder is put over the divisor, I want to explain just in probably 1 minute about why that is. Let's just take a simple 3rd grade type question, 47 divided by 3. If we were to do this, we'd say 3 goes into 4 once. Multiply it down. 4 minus 3 is 1. Bring down the 7. 3 goes into 17 5 times. And then 5 times 3 is 15. Subtract, you would get a remainder of 2. So one way that you did this back in the 3rd grade was you put 15R2. Another way that you did this was your teacher said, now we want decimals. So what you did is you put a decimal point right here, and then you put a 0 down here because you dropped it, and then you kept on dividing and using that same algorithm. What you could do as well is you could also say that this is the same thing as the remainder, which is 2 over the divisor. 47 divided by 3 is the same thing as 15 2/3. You could do it on your own calculator. 47 divided by 3 equals, math, enter, enter, and you end up getting 15 2/3. So that is why whenever we get a remainder, all you have to do is put that remainder right over what the divisor is. And that's a sure way that you're going to get the right answer. Whenever you get a divisor, just make sure you put it right over the divisor. Whenever you get a remainder, make sure you just put it over the divisor. All right, we got 2 left. X cubed minus 64 divided by x minus 4. Your first step, you know what it is? It's going to be drawing this division bar. And now you know that all you have to do is bring down the coefficients of your dividend, which is 1x cubed. Remember the placeholders. 1x cubed, 0x squared, 0 x's, and a -64. We're going to have 2 placeholders in for this one. If you want to write it out, it might not be a bad idea. X cubed, how many x squareds do you have? Well, you don't have any. After x squared, you'd have x's. How many x's do you have? You don't have any. And then after x to the first, you have your constant term, which would be a -64. So that's where all these numbers are coming from. 1x squared, 1x cubed, 0x squared, 0 x's, and the -64. And on the outside of our division bar is the opposite of this x minus 4, which is the +4. So a +4 is going out there. Now hopefully you have become more comfortable with using this algorithm. You drop this 1 straight down, and then you multiply. 1 times 4 is 4. And then you add 0 plus 4 is 4. And then you multiply. 4 times 4 is 16. And then you add 0 plus 16 is 16. And then you multiply. 16 times 4 is 64. And then you add a negative 64 plus 64. We get a remainder of 0. So if this is the case, 1, 4, and 16 are our coefficients of our polynomial from 1 power down from the highest degree of x. Our highest degree of x is x cubed. So that means this 1 represents the coefficient in front of x squared. So we have 1x squared plus 4x plus 16. And this is our answer. Same thing that I talked about in the first video of this lesson. If you wanted to, you could multiply your quotient, which is what we got, multiply that by our divisor, which is x minus 4, and you would get your dividend if you did it correctly. So you could always do that to check your work if you would like to. Last one, why don't you guys try number 8 on your own, pause the video, and then check your work with mine after you've worked it out. All right, as you can see, our dividend here has an x to the 5th term. So that means that we should get 6 terms in our division bar. So if we write our division bar, we got to make sure that we put in our placeholders. It's going to be 1x to the 5th, 0x to the 4ths, 0x cubes, a negative 3x squareds, 0 x's, and a negative 20. This is a big one. So we have 1, 2, 3, 4, 5, 6 terms in our division bar, and like I said, if your term is 5, you should have 6 terms in there. So now we have this x minus 2 as our divisor. We're going to take the opposite of that and put the positive 2 out here. So now this one, you're really going to get comfortable, hopefully, with doing this pattern of multiplying, adding, multiplying, adding, multiplying, adding as you go to the left. Let's bring down our 1. 1 multiplied by 2 is 2. And now we add. 0 plus 2 is 2. And now we multiply again. 2 times 2 is 4. And now we add. 0 plus 4 is 4. Multiply 2 times 4 is 8. Add a negative 3 plus 8 is 5. Multiply 5 times 2 is 10. Add 0 plus 10 is 10. Multiply 10 times 2 is 20. And yes, we have no remainder again. For some reason, I like the ones where we don't have a remainder, just because the remainder is just kind of annoying sometimes. That's in my opinion. Maybe you guys like it. I don't know. So these numbers, 1, 2, 4, 5, and 10, represent our coefficients from 1 power down from the highest degree of x. Our highest degree of x is x to the 5th. So this one right here represents the coefficient in front of x to the 4th. So it is 1x to the 4th. And then we just go in descending order from there. Plus 2x cubed plus 4x squared plus 5x plus 10. Whew! X to the 4th plus 2x cubed plus 4x squared plus 5x plus 10. And there is our answer, class. I hope that synthetic division made sense to you. Not only do I hope it made sense, but I hope that you see the value in how quick this can be as compared to long division. And hopefully you could see how much less time consuming and paper consuming that this is as well. It's definitely a more efficient way in my opinion. So here's what we have for our assignment. You have 2 objectives for homework, objectives 41 and 42. However, as you do this, I believe objective 42 has a couple in there that I don't want you to do until you watch the next video, which is going to be tomorrow's lesson. It says don't divide by coefficient other than 1 until tomorrow. So as you can see, every divisor that we've had has been like x plus 4 or x minus 3 or something like that. You've never seen 2x plus 4 or 4x minus 3, something like that. Your coefficients have always been 1s, 1x and 1x. So if you ever see a coefficient other than 1, so if you ever see 3x minus 2 in accelerated math, or if you ever see like 5x plus 1, if you see something like that, don't do that if you've only watched these 3 videos on 5.3. Okay? I want you to save that until you've watched how to do that video, which is going to be synthetic division with coefficients other than 1. So just for now, do objectives 41 and 42, except skip all the ones that have your divisor as being a coefficient in front of the x other than 1. I hope that makes sense. Let me know if you have any questions.